If you recall, the mean value theorem for derivatives stated that if you had a continuous curve at any point between them, you were going to have the secant slope realized at a certain point by the tangent slope. That was the mean value theorem that we saw before for derivatives. Now we're looking at the mean value theorem for integrals, for integration. This one says that if you have a continuous, gotta be a continuous curve again, there's going to exist a point C in AB such that f of C is equal to the average value. Again, so the average value is 1 over b minus a times the integral from a to b of f of t dt. Okay. So what they're saying in this picture is that if you have that continuous curve again, that average value, which we have been finding from the previous graphs, must exist at some point between the intervals. So there's a point between the two endpoints where that point has y value equal to the average value. So it's taking the average value theorem that we found before and stepping it up one more time and looking at a place where you're equal to it between the endpoints. So let's take a look at an example of the mean value theorem for integrals. All right, so in this question, we want to find the point or points exactly and 4 places for which the function 2e to the x equals its average value on the interval from 0 to the natural log of 2. So I'm assuming natural log of 2 is about over here. That's where my graph starts dashing out. And we're going to verify with the labeled graph. Okay. So the first thing we want to do is find the average value. So the average value is 1 over, so my interval is 0 to natural log of 2, so 1 over the natural log of 2 minus 0 times the integral from 0 to the natural log of 2 of 2e to the x dx. So that's 1 over the natural log of 2, and then if I integrate, I can integrate this right away. The integral of 2e to the x is 2e to the x, bounded between 0 and natural log of 2. Okay, so let's keep going. We're looking at 1 over the natural log of 2 times 2e to the natural log of 2 minus 1 over the natural log of 2 times 2e to the 0. So plug in top bound, plug in bottom bound. Okay, so I have 1 over the natural log of 2 times 2 times, right here in the e of the natural log of 2, those are going to simplify using inverses and give me 2, minus 1 over the natural log of 2 times 2, and then e to the 0 is 1. And so we'll be able to simplify this into, I've got 1 over the natural log of 2, I've got 4 of them here, minus 2 of them here, so I'm end up with just 2 of them. So 2 over the natural log of 2. All right, so that would be the exact value. And we also want its decimal value. And then we also want to know the point. So I don't have the point yet. I'm going to get that in a second. Let's get the decimal value for 2 over the natural log of 2. So this is approximately 2.8854. And so on our graph, we're looking at a point, let's see, this is 2, 3, so 2.5, 2.8, about here, say. And so we're looking, and hopefully the value is going to be below 0.4, but close to 0.4 once we find it. That's what it appears graphically up here. Okay, so now we need to find it. And so to find it, first, we know that f of x is continuous on the interval, so 0 to natural log of 2. And we have found what f bar is, and so we can say that there exists a c in the interval 0 to natural log of 2 such that f of c is equal to f bar. And now that we found f bar, we know that that is 2 over the natural log of 2. So now we want to solve for it. We want to solve for it exactly. So I'm going to set f bar equal to this value. So I'm sorry, f, this is f bar. So f equal to this value. So f of c, so 2e to the x becomes 2e to the c, equals 2 over the natural log of 2. All right. If I divide 2 from both sides, that's e to the c, equals 1 over natural log of 2, and then if I take the natural log of both sides to solve for c, we have c equals the natural log of 1 over the natural log of 2. I'm just going to get this simplified and cleaned up. Using the quotient property of logarithms, this is the natural log of 1 minus the natural log of the natural log of 2, and the natural log of 1 is 0. So c is equal to negative the natural log of, hi graham crackers, 1 second, the natural log of 2. Now, let's find out what that the decimal value of that is so that we can verify. Hey, 1 second. Okay, so calculator, and so we want to calculate, well, actually I should have left it there, but that's okay. I want to calculate negative the natural log of the natural log of 2, and the decimal for that is approximately 0.3665. So that matches up nicely with what we had expected up here, that we were going to be somewhere in the 0.3 range. 0.3 is here, 0.4 is there, 0.36 looks very nice for that point. So that is the ordered pair, or that is the c value that gives us the average value.